Hello, everyone, and welcome to a new webinar made by Deconstruct. Today, we are going to talk about how to train your tech team on the robot operating system. On ROS, of course. And then we are having some problems with the mic, but I think that we have already solved, yes? So if you can hear me, please just type 1 in the chat that is beside the webinar, and then I will know that you are listening and everything is working fine. Can you do this for me, please? Okay, great. Thank you very much. And so we have solved the problem. Then let's continue with the presentation. Then first, before everything, let me tell you about the evolution in robots that are using ROS, how it is increasing in the last year. And you can see in this picture how this number of robots that are fully supporting ROS is increasing year by year. Also, we can see something similar in the search of ROS jobs related to robotics. So the number of companies that are requesting people with the skills of ROS, it's increasing year by year. Okay, so then if you are a company and you are still not learning ROS, not proficient with ROS, then you should learn ROS. So what is my goal today here for you is to show you how you can equip your team with ROS knowledge and how to do it fast. Okay, so let's go how to do this. And what you will learn in this tutorial, in this webinar, is which ones are the main subjects that you must teach your team, or that your team must learn. Maybe you don't have to teach it, but they have to learn. Then how can you build a learning path for your team that is very fast, that is optimized? And finally, I will show you how you make your team learn ROS in 5 days. Yes, in 5 days. Maybe you're a little bit skeptical about that, but let me show you this comment that one of our users of our academy that uses this method, and that he has been using our method at the University of Luxembourg. And then he says that he used the method to teach some people that didn't have any previous knowledge in ROS, but any previous knowledge on robotics. And in just 3 days, people were already understanding the concept and using it to make the robots move around. Okay, so this is not us, it's somebody that has used the method. And let's see, what is this method? And if you stay with me to the end, I will tell you how you can get some bonus apart from this webinar. That the bonus include the slides of this presentation, and also a PDF extra with some more details about specific questions about how to do it, how to implement in very specific things. So with this webinar, don't worry, you will get the whole knowledge. The PDF adds some extra details. Okay, so what we are going to do again is to have your team ready in ROS in a record time, so very fast, with little preparation from you, and without having to manage them as much as possible, as less as possible, I would say. So you don't have to manage. They can learn by themselves, and you don't have to be supporting their learning all the time. And then maybe many of you have already tried to do this, but you had some problems because you tried to understand how ROS works, but maybe you didn't get it right, so you didn't understand fully. You tried to follow the tutorials that are on the internet, but you felt frustration because it took you so much time to understand the basic things and how to apply to real robots. Maybe you also tried to install ROS and Gazebo to do some tests, and then you had some problems. This doesn't work for this computer, for this car, for this operating system, whatever. So if that is you, if you answer yes to any of those situations, then I understand you, of course. So don't worry. because I have been already on that situation. It also happened to me many times. And that is why I decided with my team to build this method in order to improve the learning. And this method is a very already used, it's a very well-known method that is used for people who want to achieve a very, very fast learning on anything. You can apply the same method to any subject. And we are applying this to the learning of ROS. We have based the method by some of the books that you can see on that slide that you can read in case that you are more interested. But basically, the method consists in 4 steps. First, we deconstruct ROS. We learn what is ROS. We know what is ROS very well. And then we know which are, by deconstruction means, which are the main parts of ROS and how those parts connect to each other. Then, from those parts, we identify the 20% of them that will produce the 80% of the knowledge. There is a lot of knowledge of ROS that you may learn there that will only increase your general knowledge of ROS, the general understanding of ROS. You will increase that in a very little. So you don't need to learn everything from the beginning. So let's identify the 20% that is going to produce the highest impact. Then we remove the rest, forget about it. And then we make the people practice on those 20%. Practice, practice, practice. That is the key. Okay, so that is the method. And by the way, I didn't present myself yet, so let me introduce myself. My name is Ricardo Tellez. I am the CEO of Deconstruct, and Deconstruct is a company where we develop tools for learning how to program robots and tools for programming in an easier way the robots, basically using ROS. We concentrate on tools that use ROS. And I have been using, by the way, this method that I am showing you here to teach students at different universities. This is one example that the classes that I am providing now every week at the University of La Salle here in Barcelona. But this is just an example. So you have seen before another person that was using this at University of Luxembourg, and you will see more people there. Well, so before we start, the question is, again, so how you try to follow the ROS wiki and then you move very slowly on this, or you try to put some of your team members to learn through the ROS wiki. That is the basic way of learning. There is the typical way of learning ROS. And then you felt frustrated because the advancement, the learning was very, very slow. So that's the question. If you are here, then that's the proper place to be, this webinar. Let me just show you another comment from another person. Is a teacher at the University of Valencia that is using the construct system also to prepare a class on ROS and teach to people also that had no idea about ROS. So what I meant with this is that you are in the proper place and that our method works. So let's see what is this method, okay, in detail, so you can implement this method with your team. Great. So first of all, as I mentioned, is the deconstruction of ROS. This means we have identified the basic parts that any ROS programmer has to know, has to learn, and in which order. And this slide here shows what is this path. For example, at the beginning, we have some preconditions. So the preconditions indicate that the team must learn Python and Linux shell. So they have to know this prior to attack ROS. If they don't know this, bad. So they have to start first with this, because otherwise it's making the problem larger and more difficult to solve. Okay, then once you know this, then you have to learn the ROS basics. What is a topic, a service, a message, how to compile, etc., and how to debug. Which ones are the tools for debugging that we are using and how to use them. So this is the basic of ROS, subject of ROS, and that's the first step into learning ROS. Then once you have learned this, then you have to move to other subjects that are highly used in ROS. If you're programming in ROS, you're going to use this many times. So that's why you have to learn them. But don't attack this before you know the yellow part, the basic ROS. So those subjects are ROS, the TF, how the TF works, how to build the URDF of a robot, how to build the simulation of the robot, and how to control a robot. Then at that point in time, you are equipped with the, let's say, the full ROS core. And now you can attack real subjects of robotics, like navigation, perception, or manipulation. So at that point in time, you can use ROS for making the robots perform those tasks. So you have to learn how to do it, of course, with ROS. So those are the advanced ROS subjects. At this point is when I would introduce ROS in C++, because as you probably know, ROS can be programmed in Python and in C++. I don't recommend at all to start with C++ here, because it decreases the speed a lot. So you start with Python. Yes, but I don't know Python. Okay, learn Python. Yeah, but then I will have to spend time learning. Yes, spend the time learning Python because it's very easy, it's very fast, and then move to this basic path. Then at this point in time, you are equipped with in your head with a structure that allow you to understand better, a lot better, ROS in C++. So you can start showing how to do the basics and the TF and etc., all those things in C++, but only at that point in time. Then finally, you can attack the problem of applying all this knowledge into programming specific robots that you may have, you have bought, you have built, etc. So that's a specific ROS application. That is the construction of ROS, and that's the path that I propose you. I will show you how you can use this deconstruction to follow the different tutorials. So just wait with me. So basically, this is the stuff that your your team must learn. As Linux, Shell, C++, or Python. I recommend Python, so C++ in a later part. ROS basics, ROS TF, URDF, how to debug, navigation, perception, and manipulation, and how to program your own robot. Okay, so how do we build this learning path for our members of the team? How do we build this? Okay, so you will have to do 4 steps. First one, make the team use Python. Okay, so yes, I know that many of your team members will say, yes, but I don't know Python, so I have to start learning Python. Yes, and I will show you how very fast. Then you will have to install ROS using a Docker container. That's a lot easier than the typical installation, and it works in many different computers without a problem. Then you will have to prepare the gazebo simulations for practice. I will show you where you can get some gazebo simulations, very easy and fast, already working. And then use a specific ROS wiki path for the optimal learning. This means that in the ROS wiki, there are a lot of tutorials with an order that, from our point of view, is not optimal for learning. So I'm going to provide you this optimal path of following the ROS wiki tutorials. We will discard many and we'll go jumping from one to another. Don't worry, you are going to have the whole sequence before you start, before we finish this webinar. So let's go for the make the team use Python. So I recommend you to use those 2 online courses that are very fast, very simple, very easy, and that they work. So if you will have first to teach your people, your teams members, how to learn the Linux shell, use this online course, and then make them learn Python using this online course from Code Academy. Both courses, they are for free, so you can go there, enroll, and do it. Done. So we have made the team use Python. The next thing is to install ROS using Docker. This is a lot easier than installing using the typical Ubuntu commands and all that. So in that case, you just go to this tutorial. You will see it's so easy, it's so fast, and it will work in many situations of the shell, much more than if you do the typical installation by commands. So yeah, that's easy, isn't it? Okay, so we have 2 steps. Let's go for the 2 more complicated ones. Then the next one is that you have to get the robot simulations. So you will need to have some robot simulations so the people can practice on those simulations instead of just practicing on the shell with some numbers that don't make sense. So I recommend that you use simulations so the students can do the exercises in the same way, but in a simulated robot. So they will see how the robot moves, how the robot goes to one place, grabs something, etc., etc. And then in order to get simulations, you can look around internet for different simulations. We provide our own repository of robot simulations that you can find it here on this address. And it's free, so you can go there, download it, and install it into the computers of your students. It's just a Git clone, so it's going to work. And it's working. It's prepared at present for Gazebo 7. And the next months, we are going to change to Gazebo 8, but not yet. So you can use by now Gazebo 7. Great. By the way, Gazebo 7 is the one that is installed in this Docker if you use this Docker tutorial. So that's it. So we got the simulations, and now we go through the ROS Wiki tutorials by following a specific tutorial path. And this is the path that I suggest, that you follow this path. It's a 3 pages list. Don't worry, you can have it. The video is going to be recorded and exposed there on our YouTube channel. So you will be able to check it later, or if you stay until the end, I will tell you how you can get the slides, and then you will have the slides. Okay, so it's 3 pages. This is 1, this is 2, and this is 3. I'm not going to go into the details, but basically those lists, they follow. If I'm going back, I'm going to move back in the presentation. So if you check the deconstruction of this, so the tutorials, they follow this order. Okay, so up to here, up to navigation. So they are telling you how to do all this. Then we are not including perception and manipulation because that gets a little bit more fuzzy, more difficult to handle. But if you follow the list of the tutorials that I propose, you can have this order, as I express here, including navigation. Then the rest is on you, of course. 1, 2, and 3 pages. Great. So yeah, I presume that you will be thinking, hey, but that's a lot of work also, because even if many of the things are already done and very simple like this, learn shell, Python, just go there, they will learn because it's very easy and very well done courses. For the Docker is something that you will have to prepare for your team, but it's also simple. Even your team can do it because it requires almost no knowledge, just a little bit of knowledge of Linux shell. And this is the one that maybe if they don't know Git, but they must know Git, of course, because they are programming. So it's just copying this and then following the tutorials. Okay, so it's some work done that you must prepare or your students must do before starting. So what I'm going to propose to you is an option that you already have, that is to get everything already done for you. So you don't have to prepare anything. Just point your students, your team, to one place. And it's this place that we call the Robotics Academy. If you use the Robotics Academy to teach your team members, then you will have to prepare nothing at all because it's already prepared. You will have to manage nobody because the whole system provides the different courses in units that they must follow. And also we provide a support team that can answer the questions of the people on real time. We have a chat, a direct chat that they can chat with our team in case that they have problems. And also we have a forum where they can post many complex questions and we'll answer them. So you don't have to manage them. They will learn by themselves and rely on us for questions, not bothering you. And of course, you don't have to care about the computers because our system works on a web interface. So you don't have to prepare anything, not install nothing. They can use any computer. A Mac in this picture is being used with our system, or a Windows machine, or a Linux machine, whatever. They only need to have a web browser, and that's all. So this is how it looks, our system. I'm going to show you a demo later, but just to give you an idea, on the left-hand side, we have the lessons. Those lessons follow the structure that I have presented in the deconstruction of ROS. So they are based on a lot of practice. So it's not the wiki tutorials that you can find here. It's some material that we have developed on that premises, on the 4 steps of fast learning that I presented to you at the beginning. And we relied a lot on practice. Then here you have the lessons on the left-hand side. On the middle top, we have the IDE for developing the programs, the packages, the files, the Python files, the Python programs, etc. Then here beneath, we have the shells where the users can compile, edit, launch new programs, check the topics, etc. And then here we have the simulation that shows the robots, the different robots that we use for the different lessons. And the student can see in real time what is happening to the robot. So if they are doing it correctly or not. So everything is integrated on a web page, and you can reconfigure this in many ways. So we have created, of course, courses based on the list, on the path that I have shown you before. And it's for beginners in 5 days, that if you dedicate 5 days, you can learn ROS in 5 days. You can get up to speed. Specific courses for TF, control, or URDF. And also more complicated subjects like ROS navigation. We have a course specific for navigation, for perception, also for manipulation, and other subjects like OpenAI, autonomous vehicles, ROS industrial, etc. Many others. You can check our webpage at roboticacademy.com, and then you will see. And also we have created courses for learning how to program specific market robots. In this case, you can see the Tiago from Power Robotics, or the Turtlebot 3 from Robotics, or here the Summit XL from Robotnik. So these courses are already available also. And in case that you want to check what is your team doing, because you are the supervisor, you can have a screen where you will see which courses your students, your team members are doing, in which state, completed, etc. You can even activate exams if you want. It's not necessary, but it's provided for universities, the exams, so they can create an exam, publish an exam to the students, and they can do the exam and be evaluated. If you are a company, then that makes no sense, but you have that option. So those are some companies that are already using our platform to teach their team members. And if your company is not one of those, then I don't know, what are you waiting for? Because you are going to get beneath all those companies that are already doing it. And let me show you what one of our users is saying also. That is a research engineer from Eltoke AS in Norway, and he was using this to learn himself this. And one of the things that he liked the most was it was very simple to start, because you're going to see it right now. You just go there with a web page, and then you are in. And you can use any computer from any location, start at home, continue at the library, finish in Tokyo because you are traveling, I don't know, whatever. This is, let me just present to you the prices that we have here. Is a subscription price. So you get a subscription quote that you must pay, and then you can have access to all the courses. And we have different plans, one for the week. So if you only want to learn something very quick in 1 week, you pay 15 euros and that's all. If you say, no, I will need a little bit more time because I cannot dedicate 8 hours per day. So that's the monthly plan for you. And then if you want a long career, it's 250 per year. So it's a lot of discount from the annual plan. And let me tell you that we are going to change this annual plan by the end of this week. We are going to increase the price to 300 euros. So if in case that you are interested on that, it's your opportunity to get until the end of the week with this price. So basically that's it. If you want to join me now, let's go to robotigniteacademy.com and let's see how it works. Let me just show you how this works. I'm going to share with you my browser so you can see how it works. And let me just do this, just a second. So if I come here, then I will type Robotic Night Academy, and okay, yes, I have. Let me just log out. So I'm going to put my account here, and I'm going to log in. So here I am. And here at the Academy, this is once you have logged in, you can create a free account and test all this if you want. And there is a free account that allows you to check the first chapter of any of the courses. So here you have the list of all the courses that we have: basics, navigation, perception, autonomous vehicle, OpenAI, TF, mapping in 3D, control, different robots, programming, drones, etc. So we have many courses. And basically how it works is that you start a course, and when you start a course, then the platform loads the system for learning. And as I mentioned to you here, okay, so I have a problem with the connection, but reconnected, no problem. Then on this side, we have the tutorials that describe the different lessons. So in this case, it's ROS Basic that they have selected, and the ROS in 5As is the unit 1. And here we have all the units that belong to this chapter, to this course. And they create here, so they explain, and they are based on a lot of practice. So they say, let's make the robot move. So here we have the simulation of the robot in a 3D. It's a physics-based simulation that works, and works with physics. So if you do wrongly, then it will fall down, etc., and break, etc. So I'm going to just change this and select a better configuration. So I'm putting here the simulation. And here beneath, you can see that we have the shells where we can issue the commands, right? ROS topic list, or I can copy this command that shows from the very beginning how to move the robot. Very, very simple things, but that allow the student to see how the ROS programs interact with a robot. In this case, I have launched a program that when I press a key, makes the robot move. And you can see how the robot is moving on the simulation. Yes, etc. So this is very quick feedback to what the student is doing. So these are different shells that you can issue different commands. Here is the simulation, as I mentioned. And of course, here is where you create your packages and your programs. You can edit them. These are very simple examples, and contains everything that you need in a ROS environment. Of course, you can also launch, for example, graphical tools like RBS, and then see the result here. When you launch a ROS, an RBS, a graphical tool, then in order to access them, you have to open a new shell by clicking on this icon here. I'm going to click. And then we are going to see how here, yeah, so here is RBS. I'm going to put it full screen. And these are the TF of the robot, as you probably know. I'm going to disconnect all the TFs. So wait, I'm going to put all enabled to false, and then just the base footprint, for example, or the camera depth. So, well, and then of course work in the same way as it works, add new things like the robot model, for example, etc. Well, you know, this is RBase. Okay, so basically that's our platform that is already provided, and you have many tutorials to follow, and to leave your team there, and they will just learn by themselves and ask us questions. Okay, so that's all. So from my side, let me finish by showing you how to get the bonus, and then let's go to the questions. So let me share again my presentation that explains how to get the bonus. Okay, so here we are. So this is the demo that we have done. So how to get the bonus is as simple as this. Send me an email to this address. This is my personal address. And then you put in the subject of the URL. I want to train my tech team fast. And then once I receive that, I will send you the slides and the PDF with the extra information. So I'm waiting here in case that you want to take a screenshot or write it down. And since this is all that I have to say, let's go to the questions. And I am here to answer all your questions. Please ask your questions on the chat that is beside the webinar. You can see there on the webinar. And then I will try to answer as best as I can. But bear in mind that there is a small delay between what you are hearing and when I'm receiving the question. So I am receiving the question, and then it will take some time for you to hear the answer. So be patient with me with that. Let's go. Waiting for your questions. First question here by Shanigan. She says, do you offer student discounts? And I'm afraid that at present, we don't offer student discounts. Our prices are very, very low already. So we cannot afford now to offer discounts at present. I'm sorry. Then there is another question by Lagan Kapoor that says, if I used your books in 5 days, then I use this on offline ROS. I mean, only on install ROS in Ubuntu. Okay, I don't know if I have understood properly your question, Lagan, but let me tell you. So for those of the audience who doesn't know, we also provide this knowledge of the courses, of the online courses, on a series of books that are called ROS in 5 days. And then we have ROS Basics in 5 days, ROS Navigation in 5 days, ROS Perception in 5 days, and ROS Manipulation in 5 days. And then what Lagan is asking is, if you use the books, then you can use the knowledge of the books, you can use it in our development platform that is called the ROS Development Studio. On the ROS Development Studio, you will find some of the simulations that on the book are mentioned, so you can kind of use those simulations for doing your job. Otherwise, you can install the simulations from our Git in your own computers and do the exercises. Then I have here a question by Arturo Torres, who says, could you put the email again? Yes, sure. I'm going to write it down here. But please put the subject, is very important, because otherwise I will not find your email. So here it is. Any other question? Okay, my pleasure. So, any other question? Was it clear? So, do you have your teams already know ROS? Are learning at present? In which state are you? Why have you attended this webinar? Maybe you are thinking about creating a new team, and that's why you attended. Maybe, I don't know. There is a question here from Krishna Agragal. Is it possible to run ROS on Windows? Okay, at present, it's not working very well. So you can run some things on Windows, but still is a project in process, so as far as I know. And then you can visit the web of ROS to check the current state, but it's not yet finished. I mean, as the Linux version. Then in case that you want to run ROS on your Windows machines, you can use our platform, of course, because our platform works on any type of operating system, Windows, Mac, Linux, whatever. Because it's actually, you are not programming on your computer, you are programming in our cloud, but using a web interface. So that would be. How many people is interested here on programming ROS with Windows? Just say a +1 there. Write a +1 if you are. Okay, so I have a Spencer Pulking asking, how does the construct work with USB? And I really don't understand your question. What do you mean by with USB? What do you mean? If you plug some device or something? Okay, two people are interested in programming ROS on Windows. Interesting. So Spencer, I really don't understand what you mean by working with USB. You mean by if I plug in our computer a laser or something? In the construct, we work with the simulations of the real robots. So basically, you don't have to plug anything in the computer because the whole robot is simulated. And that simulation is like if you had the real robot here. We have done some interesting experiments, teachings at the university by making the students that I showed you before on the picture. Those students were all learning to program ROS and navigation for robots using our platform. And then everything is on the simulation, tested on the simulation. But then there is a day where we put into real robots what they have programmed. So they test on the platform, on the online platform, they test everything until it works. And then we just download the packages and put the packages on the computer of a real Turtlebot. And then the Turtlebot does exactly the same thing as what it's doing on the simulation. So in that case, is how we work with real robots. And that's actually the real way of working with real robots. You first try in simulation, and then once it is correct, you move into the real robot computer and try there. Then it says, here Spencer is clarifying his question and says, is there any difficulty in communicating via a serial port, IP address, or other hosting network? I guess my bigger question is if you can work in a real robot and simulation at the same time. Yeah, okay. Yes, you can do it, but not with the Academy. When you use the Academy, you have to download the packages, and then you put into the robot. Yeah, okay, so he says that I answered your question. That's how you do it. In our development tool, however, that is called the ROS Development Studio. In this tool, I'm going to provide you the address here. Sorry, I misspelled it here. Yeah. So on that tool, you can establish a VPN connection between your development on the cloud and your real robot in your beside your computer. So you can establish this VPN and then use the programs that are developed on the ROS Development Studio to be executed there, and that take action on your robot, on your local robot, real robot. So Krishna is asking, can you explain in detail how ROS Gazebo is different from other simulation platforms like BREP? Oh, yeah, so in detail, that's funny, yes. So basically they are physical simulations, both of them. So they contain, what I mean by that is that they contain physics. It's not just a visualization or a kind of game. You know, it's like if you push something, then this something will receive these forces like close to reality, like in reality will happen, and then react in the close to reality ways. So both of them are like this. VREP, if I know enough, then it's based on a physics engine that is called Bullet. And ROS Gazebo, you can use several different physics engines. You can change it depending on what you want to achieve more on the simulation. You can use Bullet, of course. You can use ODE. You can use another one that is Dart, and there is another one that I don't remember now the name. You can check on the website. So that's one of the main differences, I would say. Another one is that Gazebo is directly coupled to ROS. And BREP can also work with ROS, but you need to do some, let's say, tricks. So extra work, let's say. So Gazebo is better in that sense, and that's why it's very popular among the ROS people. BREP, on the other side, is quite spectacular in visual terms, a lot more than Gazebo. It's more visual. But that's it. Behind the Gazebo team, there is a full team that is the team that is developing ROS. So, and they improving very, very fast, and they are putting a lot of effort and money on that Gazebo. So, my bet is for Gazebo, of course, because I like it very much, and I know the people that is behind, very professionals, and that they are working very hard. So in just a few short time, it's going to be the best simulator for robotics, yeah, with ROS. So any other question? Any other question about are you individuals, if or are you team members? So are you looking for a way of training your team, or maybe you are trying to train yourself, just yourself? Or because this webinar was targeting, of course, everybody. It's welcome, of course, but it was targeting the teams, for training of teams. But from the questions that you are asking, I feel like you are more like individuals that are interested in learning ROS. And I'm very happy, okay? Just wanted to understand the audience. So any people from the universities, maybe, or from companies? So Jeffrey Louis is asking, what would you do to design a course curriculum for ROS? So that's exactly what I shown here on the slides. What I would do is to, let me go a little bit back here on the slides. But what I would do is to go, let me see. So let me go back here. Let's see, not here. Let me go back where I have the tutorials here. So yeah, so what I would do is to first get some simulations that I would like the people to work with. Then grab those tutorials and put them into that would be the curriculum. So in this order, maybe I will write it down with my own words, but if you don't want even, it's just pointing and follow these lines. So you will have a perfect course curriculum for ROS for optimizing the learning. So you will have the simulations here to work with, and then use the tutorials for explanations of that. And that would be my curriculum. Spencer is asking now, I am a member of a graduate robotics program in mechanical engineer at University of Tulsa. We have 4 graduate students and focus on undergraduate tendon networks and the synergies of grasping. Wow. That is impressive. It's quite complex. So I don't know your reasons to stay here for ROS. So why are you interested in ROS then? What do you suggest for a new programmer who is trying to train a team that is entirely unfamiliar with ROS? Wow. So what I suggest in this case, of course, is that you first, if they are unfamiliar, new programmers, first, they have to learn Python and the Linux shell. I know, I have seen it many times. Mechanical people or electronic people that they want to get introduced into ROS because it's very related to robotics, mechanics, electronics, all this are very close to robotics. So they get into the ROS world attracted. So, and they have to learn how to do it, but they don't have many experience on that. So please, what I would suggest is that you don't start using C++. You are going to have a terrible time. It's increasing in the difficulty in orders of magnitude. So the first thing is to go back. Let's go back. So, and then you apply this to your team. Let's learn Linux shell and Python. Very simple courses. Very simple, but they go straight to the point. They make you practice, and then they will learn those 2 things: Linux shell, how it works, and Python, how it works. Then, if that is your situation, what you are mentioning, then you have to use our platform. I'm sorry to sell you this, but it's your best option. Is your best and fastest option because everything is provided. Otherwise, you are going to have a lot of trouble. If nobody in your team is able to do this, to prepare this, to follow this, then you are going to have a lot of trouble. So the best option is that you get into our system. It's as simple as I shown you. It's just have a browser and start with the lessons. And we have hundreds of students that they send me, hey, I have learned more in 3 hours than in 3 months I have learned more in 3 hours in your platform than in 3 months looking through the internet tutorials and stuff. It's going to, because it's, yeah, for the newcomer, it's quite difficult, I know. So that's what I recommend you. But otherwise, you can follow the list. If you don't like my suggestion, you can follow the list of tutorials that I put in there in order to understand the fastest. Then Spencer says, thank you. I agree about C++. Your Robotics Academy is a good place to start for a research team with some other coding experience and robotics. Do you recommend the Academy more? Or, okay, in that case, if you have experience, then it depends. It depends on you, on what is the amount of time that you would like to dedicate. If you want to go fast, no system in the world is faster than our academy. No system. Our system is the best, is the simplest, is the one who works faster, and has been accessed already by many hundreds of people and many companies also. So that's the case. If you want to go, you have time, and then you say, yeah, well, okay, but I have time because that, then just go to the ROS wiki, and follow the tutorials one by one. That's how I learned. That's how I learned ROS, of course. And another option that you have, it depends on the people, is to buy some books that you can check for ROS books on the internet, and then you will find some books there also. So this is for people with some experience. What I would recommend is that you use simulations always in order to check the results in the simulations, not with numbers. So if you are trying to learn how a topic works, how to publish on a topic, it's not the same for the brain. It's not the same if you publish a number 3 than if you publish the speed of the robot and makes the robot move. So your head will understand very clearly. So, and when you should use a topic and for what, you know, because you publish here and then the robot moves. Oh yeah, I understand topics. Otherwise you publish here and then you get a 3. Okay, I understand this, but I don't see the point. You know what I mean? Yeah. Okay, so those are my advices, even for people with experience. Geoffrey Louis says, are there any instructions for operation of your simulation samples on Bitbucket? I cannot promise. In some of them, maybe we'll have, in some others, will not. Will not. So I cannot promise. So yeah, you have to check by yourself which ones. But what I can tell you is that they work. So usually what we do is we create a main.launch, and that's the launch file that you have to launch in order to start the simulation. So this is our agreement between all the engineers of the team, is that we'll put a main.launch in one of the packages. I don't know, it depends on the simulation, but that, if you localize this main.launch, that's the one that you have to execute, so the simulation will start. Then Spencer says, the development studio. Okay. Okay. Yes. See. So this connects with your previous question. Okay. Well, then, yeah, you can use also the ROS Development Studio for experienced people. Actually, the ROS Development Studio is for people who knows how to learn, how to program in ROS, and that wants to develop. It wants to develop ROS programs. So that's the Development Studio. Geoffrey is asking another question. Some of the packages have just an independent launch file, but there are any dependencies. Yes, so the packages of the Bitbucket, I presume that you're talking, is that the packages of the Bitbucket, maybe they do have some dependencies, but if there are dependencies, are just ROS packages dependency. So it's not something strange. And you should be able to install by doing a apt get install ROS hyphen Indigo or Kinetic, it depends on your version, hyphen, and then the package that is suggesting you with an error or something. So it's as simple as this. We only rely on ROS dependencies so that you can install very simply. Then Mukul Birmani is asking, is your product freeware or are you guys charging on users basis? So our academy is a subscription, so it has a charge, but you can access the academy, create a free account right now and use the first chapter of each course that we have. Okay, guys, there are no more questions here, and I think that it's time to finish because it's almost 7 already. And it has been my pleasure, really, to have you all here and answer your questions and provide you with this information. Let me know if you have any questions. You can contact me at the email that I explained to you, and I'll be happy to answer your questions and see you around in other webinars that we have. So thank you very much for attending and keep pushing your ROS learning. Cheers.